Compost is fuel for your garden. It's the perfect resource that you can put straight back into your food cube to replenish all the nutrients and minerals that you take out when you're harvesting. Now, the bottom line is, if you have really good quality compost, you're going to have healthier and tastier vegetables coming out of your food cube. Composting is also about closed loop living. You can take a lot of the resources, the waste resources that you accumulate in the home, such as food scraps, office waste, cardboard, all sorts of different things. And instead of that just going into landfill, you can reuse it to grow food for yourself. Composting is also a great way to reduce your carbon footprint. When organic matter isn't composted properly and it goes into landfill, it releases a gas called methane, which is 25 times more potent than carbon dioxide as a greenhouse gas. So by diverting all of that organic matter from going into landfill and using it in your compost, you're actually recycling all those nutrients back into your garden and into your food cubes, and you're also reducing greenhouse gas emissions. So today I'm going to give you a few tips on how to make compost in your own home using ingredients that are readily accessible either in your kitchen, in the garden, maybe even in your office, and if not there, from your local garden centre. Start off by choosing a spot that's close to your garden, accessible by wheelbarrow, and isn't receiving too much direct sunlight during the day. Otherwise, you might get too much water evaporating out of the pile. So I'm sticking some agricultural pipe at the bottom of the compost pile. So Aggie pipe has slits in it all the way along, so this will help oxygenate the pile. So I like to think of composting as habitat building. You're trying to build the ideal habitat for these microbes that will transform all of this material into compost. So I'm starting by adding a layer of pine bark mulch, followed by garden waste that we pulled out of the food cubes. An easy way to think about the ingredients for a composting system is to divide them into two categories. You've got the browns and the greens. Now, the browns are things that are carbon heavy. So carbon is really important in microbial decomposition. It provides the energy source, as well as a lot of the basic building blocks which make up almost half of the mass of the microbial cells. For carbon in this compost pile, I'm going to use pine bark mulch, eucalyptus mulch, coffee chaff, cardboard, and sugarcane mulch. Other carbon heavy materials that you could use are, say, wood chips, sawdust, shredded paper, and fallen leaves. Now, the greens are nitrogen heavy materials like lawn clippings, plant cuttings, coffee grinds, kitchen waste, even manure and seaweed. Now, nitrogen is the main component of the proteins and nucleic acids, amino acids, and enzymes that are necessary for microbial cell growth and function. So in this pile I'm using scraps from the garden, kitchen waste, and palletized chicken manure. Carbon and nitrogen are both essential to compost, and it's important to find a balance between the two. Ideally, the carbon to nitrogen ratio of the entire compost pile collectively should be around 30:1, and it will move towards 10:1 as carbon is released from the pile in the form of carbon dioxide. Every ingredient that you actually put in the pile has a different carbon to nitrogen ratio. So it's actually not a bad idea to check what the ratio is when you add it to the pile and, adjust accordingly with whatever else you're going to put in. So, for example, say you add a lot of wood chips to your pile as your carbon source. Wood chips have a very high carbon to nitrogen ratio, so it's about 600:1, so it's really carbon heavy. Now, this means that you'll need a very nitrogen heavy material to counteract this carbon heavy material. Chicken manure has a carbon to nitrogen ratio of around 6:1, so it's a good option. However, if you use fallen leaves as the bulk of your carbon content, then the fallen leaves, they have a relatively smaller carbon to nitrogen ratio than wood chips. So if you used fallen leaves and you added chicken manure to this pile, you could likely lead to an excess of nitrogen, which will then be released as ammonia. This ratio is really hard to measure, so I think the easiest way to figure out if you need to add more carbon or add more nitrogen is by smelling it, looking at it, and touching it. If it smells bad, that's probably ammonia you're smelling, and you should add more carbon. If the compost pile isn't heating up, if it's cold and you can't see much decomposition happening, then probably add some nitrogen heavy material. So water content is super important to monitor. If your compost is too wet, it'll become anaerobic, and as a result it'll release most of the chemical energy contained within the starting organic material. Most of that energy will be released as methane, and it won't even heat up the compost pile. If your compost is too dry, then none of the chemical reactions can take place, and the decomposition will also grind to a halt. So ideally you want enough water that you can wring a handful of compost in your fist, and water isn't dripping from your hand, but it almost is. Allowing oxygen to flow through your pile is also very important. And the particle size and shape of the materials you use in the compost can actually determine how well oxygen flows through the pile. If you use too much materials that have a really small particle size, like sawdust, the tiny dust particles can fill the void spaces where the oxygen would otherwise flow through, and this suffocates your compost pile. If you have too many large pieces of organic material going into your pile, not only will these large pieces take a long time to break down, but the lack of surface area of organic matter in your compost pile means there's less habitat for those microbes living in the compost pile. The size of your compost pile is also important. You know, if you make your pile too big, it will weigh down on itself and prevent any airflow through the pile. If your pile is too small though, then the heat generated in the pile will dissipate really quickly, and that pile won't be able to retain any heat. The temperature of a compost is the best way to determine how well your compost pile is going, you know. So if you can balance all of those factors, the carbon to nitrogen ratio, the water level, particle size and shape, airflow, and the size of your pile, that compost pile will become an ideal habitat for microbes. That will make the compost heat up, and it'll accelerate the composting process, and as it gets hotter, it can also kill weed seeds, plant roots, and also pathogens that are living in your compost. If you're getting serious with your compost, there are other things that you can add. Rock dust or ash to replenish the minerals in the soil, char to improve soil structure and water retention. Clay is also a good additive to improve the cation exchange capacity of your soil, which is basically the soil's ability to trade minerals with plants. You should be able to purchase most of these ingredients at your local garden centre. You'll know the compost is done when it's a nice rich brown colour. It's spongy when you compress it, but crumbly when you break it apart, and it smells like the earth. All right, so this compost is ready to go now. Just a reminder, you want to make sure that you're checking up on your compost fairly regularly to make sure it's got enough water, enough oxygen, so make sure you're turning it maybe once a month at least. And also just check up on the temperature of your compost. So this compost pile should take about 3 months to break down completely. And then once it is, you can get it, put it in a barrow, put it into your food cubes and grow some beautiful food with it.
It's been about 2 weeks since Ben explained the finer points of how to make a really good compost. So I'm going to do the big reveal today. I'll strip this back, and I've got this nice big temperature probe. And if this is working well, it should be getting close to 50 degrees as the beneficial bacteria starts to really cook and get going in the compost pile. We want that heat to help sterilize the material and break it down more quickly. So let's see how well Ben's done. So I can see the temperature jumping. It's already up at 43 degrees, 44, 45. Looks like it's going to get very close to 50 degrees. So that shows to me that Ben's pretty much nailed it, and we've got a really nice, neat, well put together compost heap here, just as the temperature nudges 50 degrees. Spot on.